Hello everyone, my name is Garima. Welcome back to my channel Physics by Garima. In this video, we are going to cover rest of the questions that are asked in April 25, 2026. Let's move to the question number 41. A charge of 5 into 10 raised to power minus 6 coulomb is moved from point A to point B, and the electric force does work of 1 into 10 raised to power minus 3 joule of work. The potential difference between A and B is, here the charge is given as 5 into 10 raised to power minus 6 coulomb, and it is moving from point A to B, and the work done is 1 into 10 raised to power minus 3 joule. So we know that potential difference is equal to work done in carrying a unit positive charge from point A to B, that will be equal to, so work done is given as 1 into 10 raised to power minus 3, and charge is given as 5 into 10 raised to power minus 6. When we solve this, it will become 200 volt. So according to this, option B is correct. Question number 42. An object is moved a distance of 10 meter by a horizontal force of 20 Newton. The friction force acting on it is 5 Newton. The increase in kinetic energy in this process is, here suppose this is the object and a force of 20 Newton is applied on this object and friction force is given as 5 Newton. So the net force acting on the object will be 20 minus 5, that is 15 Newton. And we know that the change in kinetic energy is equal to work done. This is according to work energy theorem. So work done is equal to force into displacement, and here force is 15 and displacement is 10 meter. So when we solve this, it will become 150 joule. So option D is correct. Question number 43. A bullet with the initial speed of 600 meter per second penetrates the first wooden plank and emerges with a speed of 400 meter per second. If it then enters a second wooden plank, the bullet's final speed is, here this is the wooden block, and here the bullet is moving with the velocity of 600 meter per second. When it penetrates, its velocity gets changed to 400 meter per second. Then there is another identical block too, and we have to find what is the final velocity of the bullet after it penetrates the second block. So first we have to find how much kinetic energy is required uh, to penetrate this block, or how much work is done by this bullet. So we know that the kinetic energy is equal to, change in kinetic energy will be equal to work done by using work energy theorem. So the kinetic energy, change in kinetic energy will be equal to half of m into, so this velocity square, that is 600 square minus 400 square. This will become half of m into 36 into 10 raised to power 4 minus 16 into 10 raised to power 4. So it will become half m into 20 into 10 raised to power 4. So the total energy that we will get will be 10 into 10 raised to power 5 m into joule. So this much energy is required to penetrate the block, and when it is, while penetrating the second block, its velocity is 400 meter per second. So the total energy that is carried by this bullet, that will be equal to, that is half m into 400 square. So this will become half of m into 8 into 10 raised to power 4. That will become, so, this is 16 into 10 raised to power 4. So when we solve this, it will become 8 into 10 raised to power 4 joule. So this energy is less as compared to the energy required. So when the bullet hits the second block, so it will not penetrate because its energy is less as compared to required. So the final velocity of the block will be 0 meter per second. It will be inside the block. So option A is correct. Question number 44. As shown in the figure, a small ball falls freely from air and comes into contact with the upright lightweight spring directly below until its velocity reaches zero. Which of the following statement about the ball or about the motion of the ball is correct? Here, this is the ball. When it falls towards the spring, here the spring get compressed. Since the ball is moving downwards, so it will start compressing the spring. But initially, the gravitational force will be more as compared to the spring force. So here, the gravitational force is greater as compared to the spring force. So initially, the ball first accelerates in downward direction, and when the spring compresses to its maximum, so in that position the spring force will become more as compared to the gravitational force, so its velocity will starts decreasing and until it reaches to its maximum compression. So accordingly, option C, that is after contact, the ball first accelerates and then decelerates with velocity increases first. Here, the velocity first increases because the gravitational force is more as compared to frictional force. But when it compresses the spring at that time, the spring force will be more as compared to gravitational force. So its velocity will decreases, and at the maximum or at that point when the spring uh, comes to its maximum elongation, its velocity becomes zero. So according to this, option C is correct. Question number 45. As shown in figure, a tower crane lift a building material of mass m vertically upward for a height of h using a steel cable. Given the acceleration due to gravity g, which of the following statement about the process is correct? First, we will draw all the forces that are acting on the block. Since crane is lifting the object, so in the there will be tension in the rope, and there will be a force that is in downward direction, and it is moving in upward direction, so it will have a upward acceleration a. So the work done by tension, or we can write F net force is equal to mass times acceleration. So here net force will be T minus mg is equal to m into a. So tension force will become mg plus m into a. This is the tension force. And we need to find the work done by the tension force. So we know that work done is equal to force into displacement, and here displacement is given as h. So we will put the value of tension, that is here the force will become tension, that is m into g plus a into h. So according to this, option A is correct. Question number 46. As shown in a figure, a bicycle has a front chain wheel, a rear spoke, and a rear wheel, all with different radii. Regarding the 3 points A, B, and C on their edges, which of the following statement is correct? Here, point A and point B, these 2 points, they are connected with the same chain. So these 2 points will have the same velocity. But the point B and point C, these are far from each other, having a distance of r, suppose. So the linear velocity at point B will be different at the linear velocity at point C. So according to this, option B is correct. That is point A and B have the same linear velocity or linear speed. Now move to question number 47. A car starts to accelerate from an initial velocity v0 on a straight level road. After a time t, the car's displacement is s and it reaches its maximum velocity vm. During this process, suppose that the power output of the car's engine remains constant and the resistive force acting on the car is constant. Which of the following expression is correctly represent the work done by the car engine during the force during the time? So here when the car starts to accelerate from the initial velocity, suppose this is the car and it is moving with the initial velocity v naught. After time t, suppose after time t its displacement is s and it reaches to its maximum velocity. When the car is moving the maximum velocity, that is vm, at that time the net force acting on the car will be zero. So what is the net forces that are acting on the car? That is one force, that is the force by the engine, that is by the car, that is F, and other force is the resistive force, that is F. So this net force will become zero. That means F will be equal to resistive force. Now we know that the power consumed by this resistive force, power is equal to force into velocity. So it will become force into Vm, and work done by the car during the engine, we know that work done is equal to power into time. So it will become force into Vm. This is the resistive force into time. So according to this, option A is correct. Now move to our last question, that is question number 48. A wind tunnel laboratory can simulate the wind resistance athletes experience during the competition, helping them improve their performance. To study the flow environment in the wind tunnel more intuitively, smoke particle can be used for visualization as shown in figure. In one experiment, the trajectory of the smoke particle was obtained as a curve path as shown in figure. Which of the following statement is correct? The velocity of the smoke particle is constant. Here when you draw the velocity, we know that the velocity at every point is given along the tangent at that point. Suppose this is the point I'm considering. At this point, the velocity component is like this, and the direction of velocity is in this direction. This is the direction of velocity. At every point we find that the direction of velocity uh, of the smoke particle is different. So according to this, option A is incorrect. The smoke particle must undergo uniformly accelerated. Here the velocity at every point is changing, so this is not a uniformly accelerated motion. So this option is also wrong. The direction of acceleration at point P may be horizontally towards the left. If we draw the acceleration that is acting on particle at point P is the first force will be due to the centripetal force, that will be in this direction, and this is the centripetal force, and the tangential force will be in this direction. So the net force that is acting on the particle will be in this direction, that is towards the right. So according to this, option C is also wrong. The direction of net force at point Q on the uh, may be vertically downward. Here when we draw the forces that are acting on particle at point Q, this will be the centripetal force which act along the center, and this will be the force, this is the force due to the tangential force, that is the tangential force. The net force will be in downward direction. So according to this, option D is correct. I hope you understand each and every question. Thank you for watching.